In our last video, we looked at finding a lot of things about quadratic functions. And we saw that a quadratic function was a function in which the highest exponent was a 2. So the standard form of a quadratic function is ax squared plus bx plus c. B and or c can be 0, but a cannot be 0 because then it would just be a linear function. And we saw that our vertex could be found using a formula, negative b over 2a, to find the x-coordinate. And once we knew the x-coordinate, we could find the y-coordinate by plugging that number in to the function. In this video, we're going to look at some additional important points on a quadratic function, which are the x-intercept and the y-intercept. And we have found x and y-intercepts of linear functions, and we're going to see that they have the same definition. And we're going to use some of the same processes to find them. Before we start that, I want you to go ahead and find the vertex of the function f of x equals x squared minus 8x plus 15. Use the formula, negative b over 2a, and find the vertex of this function. Pause the video and then start it back up once you have found it. All right, we have to find two different numbers. We have to find the x-coordinate. We also have to find the y-coordinate. Two different numbers for the ordered pair. To find the x-coordinate, we use negative b over 2a. A in this case is the coefficient here, understood 1. B is negative 8. So I have a negative 8 over 2 times 1, which is 8 over 2, which is 4. So the x-coordinate of the vertex is 4. The y-coordinate, the y number in the ordered pair, I plug that value in to the function in place of x. Let's see, 16 plus 15 is 31 minus 32, which is negative 1. So the y-coordinate is negative 1. We also know that because the 1 is a positive number, that this opens upwards. Let's go ahead and look at the concept of x and y-intercept. Remember, if I were to graph this function, plotting my vertex, I'd have my ordered pair right there. And I know that this is going to open upwards. So I know that I'm going to have a graph of some form like this. And remember, the x-intercept is where the graph crosses the x-axis. So wherever this graph crosses the x-axis are my x-intercepts. And notice that on this one I have 2 of them. And in both cases, I'm not moving up or down off the axis, so the y is 0. So to find the x-intercepts, I need to know where y equals 0. In other words, I set y equal to 0 and find x. And that's exactly what we did when we were using linear functions. We set y equal to 0. Remember, y is f of x. So we write this as 0 equals x squared minus 8x plus 15, and we solve for x. And this is a nice quadratic, so we use our quadratic methods. Solve this, pause the video, solve this equation for x, and then write both your answers as ordered pairs. And remember that the y is 0. So x-intercepts are ordered pairs. Pause the video, do that work, and then start the video. So I see I have a b term, so I set it equal to 0, keeping the x squared term positive. I don't have any common numbers. I don't have any common variables. I try to factor. And because I have x squared, I know I have x and x, so I think what two numbers multiply to give me 15 and add to give me negative 8. Since this is a negative and this is a positive, these have to be the same sign to give the positive, so I have to have two negative numbers. Two negative numbers that multiply to give me 15 and add to give me 8 are 3 and 5. So I set each of those equal to 0, and I get x equals 3 and x equals 5. So my ordered pairs are 3, 0 and 5, 0. And I'm going to go ahead and draw a new graph here just to be a little more careful about how the graph looks. And I knew my vertex was 4, negative 1. And now I have my two additional points, 3, 0 and 5, 0. And notice that those 2 points are symmetric around my axis of symmetry. Notice that they are exactly the same distance on either side. And that always has to be the case. Whenever we have x-intercepts of a parabola, they have to be symmetric to either side of the vertex. Let's go ahead now and find the y-intercept. Remember, to find a y-intercept, that's where the graph, if I look back here, that's where my graph crosses the y-axis. And anytime I am crossing the y-axis, that tells me x is 0. So to find my y-intercept, I'm going to let x equal 0 and find y. And remember, y is the same thing as f of x. So this is really finding f of 0. And we're going to see that that's just 15, our constant. That's always the case. Notice if I look back here at my original function, my function here. If x is 0, these first two terms are gone, and I only end up with the constant. Remember back with linear functions, when we had linear functions, we had y equals mx plus b, and we saw that the b was the y-coordinate of the y-intercept. And now we see with a quadratic that the constant is the y-coordinate of the y-intercept. And we're going to see that with every type of function we look at moving forward. The constant is the y-coordinate of the y-intercept. So back on this, our ordered pair here, x is 0, y is 15. So we have our ordered pair. We have 0, 15. And we can draw our parabola. And remember, this side has to be symmetric as well. And so this is my function f of x. The x-intercepts, you set the function equal to 0 and solve for x. The y-intercept, you plug in a 0 and it's always going to be the constant. But remember that x and y-intercepts are ordered pairs. You have to write it as a point. Let's go ahead and look at the concept of a 0. Most students know about a 0 being the number 0 between -1 and 1. But in algebra, the word 0 has another meaning. A 0 of a function is a value of x, so it's a number that makes the function f of x equal 0. In other words, it's a number that if I plug it into the function, it makes y equal 0. Notice back here on our function f of x, if we're looking at this line right here, y equals 0, this is y equals 0, the line y equals 0, the values of x on our graph, that if I plug those numbers in, if I plugged in f of 3, y is 0. If I plug in 5, y is 0. That's exactly what those two ordered pairs mean. It's the same information. So these two ordered pairs, these 2 points on the graph, and these two function value statements give me the same information. And that also means that for f of x, my function f of x, 3 and 5 are zeros of f of x. So I have all of that information. If I know that a is, some number a is a 0 of f of x, that literally means that f of a equals 0. If a is a real number, and can be graphed on the number line, then a0 is an x-intercept. So if I know this, and I know this. I also know that a is a solution of the equation if I take whatever that function was and set it equal to 0. That's literally what I did right here. I set the equation equal to 0 and I solved for x. And we know one more thing here. Notice that before I got to x equals 3 and x equals 5, I had factored this. X minus 3, x minus 5. So I know one more thing here. I know that x minus a is a factor of my function f of x. And we're going to look at these concepts a lot more when we talk about higher order polynomials, but I wanted to go ahead and introduce the concept of a zero at this point.